Goeiemôre almal. Dumelang, Sanbonani. What's the vendor? How do you say hello in vendor? Buddha? Bonjour. Oh man, now you see this thing of Ni Masiari. I doubt that's true. I feel like I'm saying a swear word or something. Buddha, are you sure it's really that? Yeah. Okay. Good afternoon. We'll be continuing with three-phase balance loads, but before I start, I just want to get a general consensus. Sorry, as everyone who has practiced the three-phase balance loads. I'll start the poll quickly. Who has practiced three-phase already? Because I'm sure you guys haven't practiced anything. Poll. No. Did it two past papers. Fantastic. How did you find it, Mr. Lecoq? I'd like to hear from you. What was last week's works? I'm not going to answer that. Well, it's okay, just long. Yep. That should be. Thirteen didn't respond. No. I'm just getting a general feel so I can see how I can assist you. All I can say is electrodes is the subject. You don't wanna. You need to be on the bus on the bus at all times. Otherwise, Mr. Silva, Mr. Mavisa, and Muda, I hope you guys can respond. I can see all your responses, by the way. Just letting you know. Who's saying yes, who's saying no? Mr. Mini saying nothing. Mr. Mudal, how are you, Chief? Okay. Not that you had to practice or anything, so it's like half, basically, right? Took some time now. Took some time to know what is clapping, or what to know what is clapping. What is, you know what? I don't know, man. No, yeah. Okay.
Oh, sorry, sir. I was just typing. I was concentrating on my son quickly, and then we didn't know what I was typing.
No stress.
Sorry about that.
No. It's cool. Is there any questions before I start? Because what my plan is now, I'll just quickly demonstrate to you. Like I said, it's a continuation of the three-phase chapter which we've covered in. I hope you guys did this question as well. We're going to do this one. This was from a test and past paper. After that, we'll go into power phase correction and talk about power phase correction, and then I'll integrate it back into this question, and then we'll end off with I'll do this example, I'll integrate another question. There's another type of question, and then basically that's the end of this lecture. So it's not that long, but if there's anything I can obviously answer now, it'd be great. Yes, Mr. Timothy Philip Lecoq.
So regarding those leading and lagging angles, when we have to do like get for each point, do we have to use a protractor to show the correct angle? Can we just put more or less the angles, or must we use a protractor?
Yeah, no. So no protractors here, just pure calculations. Is there any particular question you're referring to?
Like in the test, there was the drawings that you had to make for leading and lagging angles, and then they did the vector drawings. I wanted to know, must you use your protractor to do those vector drawings?
No, not at all. This all the time you protractors using moms. Here, there's no protractors at all. Just angles, just values. Yeah, that's just the scale. If you're asking. Yeah.
Okay.
You'll see what I mean.
Okay.
And when I do it, just stop me where you feel, guys, I don't know if you guys want to have on campus class sometime. I've no problems having that. If strengths, because I found that the strengths is also on campus, but I know it'll isolate a lot of people in terms of, yeah. So online is fine. Okay, cool. I think I articulated well. Most of my students are happy, but if people, I just want to say, if you don't understand something, please engage with me. Like really, open door policy all the way. Please ask. Don't. If you're unsure what to practice, if you need more practice, if you're not understanding a concept, please engage with me. I'm here for you. I want to pass. The course is great, very useful. Shot, Mr. Ball. So please engage. Don't sit there and I don't know. Sir, I don't understand this. How help me. Who was it? Timothy who actually engaged with me? I think it was him. In particular, the electros. Yeah, I just can't recall now. But just engage. Just ask. So I don't. It's cool. Now online I'm keeping it online. Like I said, I was just asking. So at what level do I need to get to? And I'll tell you. It's not supposed to be vague. At the end of the day, like I said to you, in totality, you're covering around 30 concepts in the mechanical engineering topics. 30 concepts, give or take, maybe 25 to 30, depending on how the other lectures are covering. So it's a lot of content you have to manage. That's what makes S4 challenging. First of all, the second reason why S4 is challenging is that the content you're learning is not particularly easy. It's not. You have to be experienced in a lot of domains. You take for granted the skills you have when you're doing all the stuff. Like the complex numbers, the angles. You have a lot of thinking to do, a lot of decision making on a quick note, especially in the test. So that's why this is difficult. It's not you're going to memorize something and boom, you're going to pass. No. You have to use your brain here. Go for that job, pump that weights, eat the right food. It's a lot of things. So that is why people fail. But what I can tell you that I am here. And you guys can do this. If I can do it, I'm sure you guys are more than capable of sorting this out. So yeah, I think that's all basically. But so I got what is it? What is it? The response is like half basically. Exam paper 2014 question 2 was very tricky. You see, this is what I wanna park that on. Let me see the cock. I've got the one I want to do, and then I will have a look at that. So November 2022. And just by the way, specifically for exams, the best thing is exams. 2022. Where is this? 2014. Oh, that's one of the old past papers of Ntamba. Let me see. Where is it under? You perhaps know. Content.
Yeah, I got it from your list.
Like which one was it exactly? I'm not sure. I got it. Party. Yeah. I got it here. Let me see. Let me tell you if it's worth looking at. This is what I like when people are actually checking. Okay, cool. Just Timothy, just remind me again on that one, or just send me a WhatsApp screenshot of the thing so I can actually just go find it. And then anyway, what I want to do is this question over here, right? Let's go into the test. The reason I want to do this is a good warm up, and then there's a second part which comes after this, which the power factor correction part, which I want to actually look at as well. So that's going to integrate all nicely with this. So this is the question we're doing today. This is at seconds level. What's remaining now is to have the power factor correction component of the question, which you'll see in the next section of the lecture, and then that is based at chief level. So this is the kind of questions you're essentially looking at. Can we do this one? Who has done this one? The solutions are posted on Blackboard, but I thought it would be worth doing again, seeing that not everyone has actually covered everything. So it's not too much talking, just the power factor correction component, and then you'll do 2 more problems and be done with 3-phase. Not a big chapter. And yeah, you guys have to pray for me so I can gather the strength to write this textbook for electrical technology in particular. So I really want to, but Yeah. Cool. Let me see here. A Blackboard format. Okay, cool. So we're gonna do this one. Timothy, just send me that question, please, so I can have a look at it afterwards, or when it's a break time, I can just see. Okay, who has attempted this question? Has anyone attempted this question? Can we do this one? Are you happy with this one before we start power factor correction? Laugh lot. I did. Yes, I think you engaged with Mr. Worth. I'm correct. Oh, Timothy, I see the question. That's for induction motors. So that's a different chapter, by the way. So you don't need to know that now. Yeah. Yeah. Oh, cool. Are you guys happy with me doing this question? Or can I move on to power factor correction? I'll leave it in your hands. That's why I did the poll, just to see how much people are. I know people are rusty in terms of, you know, some of you guys didn't do electives too, so I'm just making sure. Okay, let's throw a poll out again. Let's see. Should I do this question? And if it's favorite response, I'll do it. If not, then I will continue with power factor correction. It incorporates the same principles of what you've done. It's just that this is the kind of type of questions you might see. It's all about concepts. Obviously, I recommend practicing all the questions, but remember the concept. Okay, I only got 3 responses so far. All said yes. And please try to engage with me at each level. Please, you know, this is definitely coming in your test. Test 1, you'll definitely have a question in this vein, around 20, exactly around this marks. Yes, please. So I got 7 yeses so far, 8 yeses. Fantastic. Cool. I'm happy. People are responding. Mr. Breed, Mr. Mabisa, Mr. Soba making a response. Sipamanja. Can you guys see the poll? Okay. I got 10 yeses. Yeah, you see the thing with these types of questions, it's like you can have legit the same question and then just change all the values, and it'll change the whole, you know, the whole setup. And yeah, you know, let me just quickly see something cool here. I just want to confirm something. Yeah, I wanna go in something. Okay, everyone says, a lot of people said yes. Okay, we've reached, we're a democratic country, and therefore we will apply the same rules in our classroom, and we will start now. Okay, so reading the question first, let's zoom it in. A container shop has a 3-phase 415 volt supply at 50 hertz. This is common type story. Well, 415, well, anyway, and it consists of the following loads and motors which provide power to various equipment on board. So the lights consume 35 kilowatts. Heating, I'm thinking that could be what? Maybe the boiler or the element, who knows, or your air conditioning, 80 kilowatts. Air compressor motor consumes that much. We got a Surge centrifugal pump pumping that much, consuming that much. For the electro-hydraulic steering gear, we have 150 kVA connected in star, and what's nice there, that is leading. Can you see that you can have leading or lagging power factors all over the place? What they want, the easy part is the phase current and angles of each motor, so just the motors. Then they want the total input current and power factor for the container shell. What I want to throw in here is a special question, B, and I'm going to say, okay, can I just have it? Or say B1, and we're going to say if these loads, right, is connected to a, wow, so now we ran out. Okay, so I'll write it up again. But basically what I'm going to put there is if all these loads is connected to a 550 kVA alternator, if all these loads, yeah, is connected to 550, what would possibly happen? Okay, so that is just a bonus question. I just want to see if people understand. Okay, nevertheless, let's begin. The first thing you obviously want to do, I think what is important is to sketch. I'm realizing sketches are very important for you guys, and I'm trying to be a good lecturer and start sketching more, even though it takes a decent amount of time. Okay, so you sketch out the question. So we got our main bus over here, and that's, so obviously we have, let's just assume it's a generator or an alternator rather, and let's just assume it's all connected on there. So it's 415 volts at 50 hertz, hypothetical type question. Not sure that that's a possible configuration. And on this, we obviously just assuming it's directly coupled here, and we have, which is not always the case, obviously, because we have transformers in between. Sewage will get tripped off the load. Not as 550 kVA, but we'll see. Remember, it's in totality here. I wonder if you may be right already. Who knows? You'll see. You can debate me there. So here we have our lights, right? Obviously, what's missing here is like the transformer component of it. It will trip. Yeah, sure. The lights. We've got the heating, right? We've got the one motor A, other motor B, other motor C. Okay, so obviously, what I shouldn't actually just put the generator here. There's typically a transformer in between to get for the single phase loads. But yeah, just a hypothetical type question, assuming there's one generator is powering all these loads. So I'll call this L and I'll call this H. Okay, so for the first part of the question, they're looking at the one-to-phase currents for each motor, right? So let's go A for motor A. And what's nice about this is that all the motors are different. So what I'm testing here is you're able to do your three-phase, like are you able to see what's star and delta basically. Okay, so for motor A, they give you that, this, so yeah, we need the phase current. So how do you think we'd find the phase current? What formula would we start off with? Let's engage the class before we move on. What formula do we use for the air compressor motor? Anyone? People sleeping? Just not the power formula, but which one is?
The one for S is equals to VI.
Yeah.
Root 2 VI.
Yeah, there we go. Yeah, the parent power, but not S equals to VI, it's S equals root 3 VI. VL. We know it's root 3, it's a three-phase supply. If this question stated single phase, if that said single phase, you don't include the root 3. Thank you very much. Yeah, so be very cognizant of that. Is it clear to everyone? Do we know the difference between single phase and three-phase loads? Do you know when to use what? Is that clear to everyone? Yes. She says yes. I hope everyone understands the difference between, if I say single phase, everything changes. If I say three phase, okay, fantastic. Muda says yes, then that's the final decision there. Okay, so what we need to do is find the line current, okay? So that's going to be at, and I obviously recommend take notes as we're going so you can engage solve with me. And obviously we've got 415 volts, and then we can get the line current. Can someone just give me this line current? What is this line current? 417.36. That's definitely correct. Now my question, and then our power factor, we can easily find that using cos of second function of 0.82, and that should give me what? It should give me a power factor of 38.74, right? So you should have minus 38.74. Is this my phase current for this motor? I think it is. Is this my phase current? No, yes, exactly, it's not. And the reason, wow, what's the reason behind that? That's the line current. So what is the phase current? Fantastic. What is the phase current? Oh, thank you, 0.78, yeah. That's it. Yep, that's correct. And what is my phase current? Sorry, it is still 38.74. Yep, there we go. Fantastic. I was checking to see, because the motor is connected in delta, we are aware that your line current equals √3 of your phase current, and therefore your phase current will be this divided by √3, and it should result in 240.96 amps minus 38.74 degrees. That's around 3 marks. Are we all content with that? Cool. So the next part, we have to do the second motor, but I'll skip the second motor and I will only do the third motor. So I think my thing just went off now. Cool. So let's do motor C. So, okay, you guys can do motor B for me rather. I'll give you guys like 2 minutes. Do motor B for me. Motor B, what am I looking for? My phase current. So you guys can quickly do this because I don't wanna I wanna focus on motor C, but you guys can practice with this along. I'll just bring the question in for you. So this section is definitely about multiple loads, finding apparent powers, and then obviously power factor correction, and also putting a electrical machine in a new environment and see how the parameters change. So yeah, can you guys find motor B for me? Then I'll do motor C. Prof. Swanepoel, I concur with your answer. You guys will get that answer? Plug and play. So you should have gotten 160.64 at an angle of minus 34.915 degrees. Important, it was connected in star and it was lagging. Okay, do we all concur with this answer before I move on? Fantastic. Okay, so let me move on and not waste any time. So motor C, right? I don't know why I'm writing a B there, but anyway, let me just erase this guy. Oops. Thank you. So motor C, for motor C is connected, and you can obviously see why the stuff is intense, because you make one mistake, one misread, and then you're out. So you have to be very, very critical, and as an engineer should be. 150 kVA connected in star at 0.78 leading, right? So for motor C, we know it's star, power factor is leading. I'm just deliberately putting that there. The kVA for that, so we're going to use the same formula. And once again, obviously they can put it in power form, or they can put it in apparent power form. It doesn't really matter. You have to know what to use where. So I think we have 150 kVA. That's at root 3, a line voltage of 415, and then our line current. Okay, so just working that out quickly. Gives you a line current of 208.68. And then obviously our power factor, cos of, what was it again? This is 0.8. That should be 36.87 degrees. But plus, because it's leading, very important. This motor is behaving as a capacitor, and it shouldn't. Is this my phase current? Oh, sorry, 0.78, my bad. Okay. 38.74, sorry. Yeah, 38.74. Sorry about that. Yay. Cool. I think I modified it question. 8.74 degrees. Okay, cool. Yes, the star connection, that's correct. Your line current equals your phase current. Amazing. Cool. So is there any questions up to here? I'm assuming no questions. If you can do this, fantastic. Okay, no one's saying anything. So the next part of the question is the typical situation where we have to so now they ask you, what is the total input current and power factor for the container ship? Well, for these specific loads, obviously. So we're looking at, obviously in a real life situation, there's a lot of loads connected. It's not this basic 3, 4, 5 loads. So what you have to do is now, like we did last time, add all these particular loads. Okay, so let's see. So what I recommend always, you open up a table, you say load, you have your P, you have your Q, and obviously you can have your S over there as well. Okay, so make it like that, so we can have the lights for heating. I'm not sure what the heating exactly that is. So obviously we look for total apparent power, and then it's A, B, C, and then cool, that's the total, right? Nice. Okay, so for lighting, we got 45 kilowatts, and obviously this is purely resistive, and as your lights are, and therefore you have no reactive power because there's no electromagnetic field in this case. So for S, 45 plus J0. So if you recall, the complex power looks like that. Is everyone happy with the first one? Do we all concur? Some will say have higher power electric heating for fuel. Oh, that's nice. That's cool. Cool. Makes sense. That's nice. I actually didn't know that. Cool. Yeah, it makes sense. Why don't increase the viscosity? Didn't even think of that. Okay. Do you guys agree with my pattern power for the lights? And then for the heating will be exactly the same. And we have over here 80 plus J0. So what I like for you to do now is get I want the power over here for A and for Q, and then obviously S. I'll give you guys 2 minutes to do that. Treat this as a tutorial, before we get back into the normal lecture thing. So make sure you get A for me, please. Thank you. Mr. Ball.
Just a question: is it possible? Are you allowed to do it in polar form as well? The adding of the
Yes.
apparent power.
Yeah,
So
I'm sure.
also,
You can also do that.
as long as
Yeah,
as long as your angles are correct.
Yeah, I'm gonna. Can we do it after? Like once I do this part, then I want you to introduce how you did it. You can do it many ways. Yeah, I'm just deliberately breaking it up for teaching sake.
No, that's fine.
But we'll do it as well. Okay, just remind me. Do you guys agree with that answer? Please check. Dr. Ashipala says yes. And obviously, the one way to do it, to find individual parts, there is obviously a variety of ways to actually do this. In fact, we don't need to find all the P's and Q's here, by the way. I'm just making you aware. Let me just go to my Casio quickly and show you. We can just actually add all the pattern powers. That's the honest truth. But just to quickly demonstrate to you for motor A, what you can do is cool. So mode complex, you can just go in the 200 at an angle of what's that angle again? Minus 34.915. No. Sorry. Motor A was 300 at an angle of minus 38.74, and you should get that answer. That's to break your power and reactive power down. Okay. You guys happy with that? So 234. Any questions around that? Negative 187. Look at 188, just for ease sake. Okay. You guys content with this? Guys, are there any questions? Please ask, man. Don't feel that you shouldn't ask. Okay, so can I get for oh yeah, so man, what am I doing here? So just erasing this. You can have 234 minus J, very important, the negative 188. So can we quickly get B, C, and yeah, let's get for B and C quickly. Yeah, I'll write it in here. And I'll show you the other alternative way of getting it. 164, Mr. Cox and Fire. You guys agree with that answer? Say 1147, or make it 114.5. 164. It's not difficult at all, but you can make a horrible mistake. Yeah, 1, 1, 2. Obviously, we know what this is as well. Negative 1147 2. Okay, can I have C, please? Thank you, Mr. Seema. Are you sure it's 150? 150. Are you sure it's 150? It's 120, yeah. And what's very important, my students, my dear students, is that with this, because it's lagging, we have plus J90. Super, super important. Because it's lagging, so it's J90. So you make this negative, you're out. I stop marking just there. So what you can do now is sum up all these guys. 45 plus 80 plus 234 plus 164 plus 120 is 643. And then you have 118 plus, so it's negative here, negative there, so it's minus 118 minus 114.473, and we have plus 90, and you should get 212.473. Yeah, so negative 212.473. So your total apparent power, which we look at, is this over here. Just get that. Okay, so I'll just put him here. Your total apparent power for these loads is 643 minus J212473. Obviously, I rounded off, so it'll be slightly different. And obviously, we convert that into what is this? Into polar form. You'll get an answer. Because should get 677, I think, according to this. 195 at minus 18.289 or 286, sorry. Okay, lag. That's the whole thing. I got a different answer for C. Yeah, C, you should get. It's did I make a mistake? No, it's right. I just wrote that wrongly. You shouldn't get a different answer for C. It should all be the same. But she's just that's 120. Me too. I think C use the current instead of power. Okay, let me just confirm this. 1K. What's the problem with C? How did you guys get from motor C? So if you type in your calculator over here, let me just reshare this. Yeah. Of course, we'll do this one now. So what's the load for C? It's 150, right? Angle of, what's it in? 34, 38. Oh, did I see I probably typed in from a previous thing. It's supposed to be 38 point. Now you guys are probably at 38.74. Yeah. So it's plus 38.74. Yep, you guys are right. So it's 117 and 93.864. That's correct, yeah. So you guys are correct, sorry. It's me. Yep. Let's just recap that now. Thank you for that. I was working based on the question which I had 0.8 power factor. That's why this looks wrong. Okay, so that's definitely correct. So let me remove this, remove that. So this should be 117, and this should be plus can we call it, let's call it 94, right? Just for the sake of ease. J plus J94, and then yeah. So just give me my new totals here. That's correct. Our power factor for C is plus 38 point something. There, 38.74 lagging, leading, sorry. Okay, cool. So just can I have my new totals over here? I just threw off that 643, so that's probably that should be 640. Yep, and your total should be minus 188 minus 114.472 plus 94, and you should have 208.472. Yeah, I realized that question, test 1 is supposed to be 0.8 leading. That's why it's like that. So I have 7, 8 here. But I mean, the concept still remains the same, so it's fine. Okay, is everyone happy? Oh, and obviously I need my new apparent power here. Is everyone following so far? The total apparent power should be 673.0977 at minus 18.0424. Cool. Simple. Yep. We all content with this. Any questions before I do Mr. Ball's method? Or what the Mr. Ball's method, but the other alternative way of doing this. You could have found line currents as well. You could have done different types. Any questions before I find the parent power using the more easier form? Any questions, students? Give me a thumbs up if I can proceed. Sweet. Okay. So the other alternative is a quick way. You're just going to say S total will be S lights plus S heating plus SA plus SB plus SC, and it'll be 45 degrees at 0 plus 80 at 0. You could have added SA. SA in this case was given to us as 300 at an angle of minus 38.74. Is that A, right? Something is, yeah, it's right. Plus SB. SB was given as 150 also, minus, what's SB? No. SB was 160 point, no, where's B? Oh, sorry, it's 200 at minus 34.915 plus SC was 150 plus, the angle should be plus 38.74. That's the quick way to just basically do that. So that's your S total. And then instead of doing this whole table method, this is beneficial for certain things. If the question asks for the power of the individual motor, you can actually just, that's why you can use all of these here. So that's, but this is a quick way of doing that. Does everyone understand what's going on here? So just quickly get this answer using your calculator. That's Mr. Ball, I'm assuming you're meaning this, right? I agree with the table. We'll just ask you. No, it's cool. But You do what the questions ask for. But this is what you meant, right? Yeah, but yes, that's right. Okay, cool. So what's my total power? Can you just get it for me? So it's just showing the alternative quick way to get it. So do you guys get my total? 45. I'm just doing it here. It should be exactly the same. Obviously, we've run off a bit, so there should be some disparity, but not too much. 200. Is it 34? 3474 plus 150. And you should get 752. What did you guys get? The same 752 as well. Something suspicious. 45, 80 plus 300. That's 8.74 plus 200 minus 34 point, so 915 plus 150. Oh, I see no mistake. Plus 38.74. Yeah. So you get the same answer. So you get 673,055 at minus 18.3. 032. You can see it's quite close. Yeah. Both is completely acceptable. Okay, and what the question did ask for was obviously the total line current drawn and power factor for the ship. And that should be easy to solve. We're using S equals √3 VL and it's 673.055 kVA. It generates a voltage of 415 times IL. And you should get a total current of peak current of 956 amps. You guys get the current? 936.57796. Okay. .3577 and a power factor of that minus 18,032 degrees. That's our line current. Any questions? Are we all happy with this? And amps. kVA and amps. Are you all content with this? Happy, thank you. Now for my next part of my question, if the alternate's rated at 550 kVA, what would possibly happen? Can I open the floor for that question? So our generator produces 555 kVA and the totality of loads is 673 SL. So what's going to happen here? Can I open the floor? It'll trip. Yes. Assuming there's no protection devices, what's going to happen? You are mid-sea and let's say there's no protection devices. It'll trip. That is correct. Overheat and burnout. Fantastic. We could have a blackout. Can I ask you another question? Yep. Fantastic, Mr. Monroe. Name two ways to ensure it doesn't trip or have an outage or blackout. Name two ways to ensure it doesn't have, assuming this arrangement. It's obvious stuff. Give me two reasons quickly. Preference trip, the sewage, yeah, preference trip system, exactly. So basically what I'm looking for, you're removing one load, you know, one solution would be to remove one load, exactly, which is essentially least essential load, yeah, remove least essential load, that's correct, remove least essential. Actually fantastic. Second one, we could improve the power factor, which we'll talk about now. Because if you improve the power factor, then you'll get more parent power. And obviously the third one, possibly, if there is, maybe, you know, have another alternator. Let's say additional alternator. Let's say to put an additional, if there was an additional alternator on board. But understand the concept. What's happening here? Are you guys all aware? Is the concept clear of what we're trying to achieve? You understand what a parent power is and all of this. So can we move on to the next question, the next part of the question? Are we all content? Okay, just the concept is what's important. Yeah, I mean, obviously it's like a theoretical example, but yeah, just the concept I want to be highlighted, and plus the calculations. Okay, so the next part of the question, it's a very long question. So let's remove this. Oh, not that. There is this. That's just to see your understanding of what this is about. Okay, so we arrive on port, and what we do now, the second engineer, assuming you're the chief, takes out motor C because we need to power a container crane. But now, when we're on port, let's say we are in where it could be possibly, let's say in America for argument's sake, and now it has different supply in terms of well, we have a different supply voltage of 317 volts and a 60 hertz. So we have a different frequency and different supply. What we need to do now is we're going to put the motor online, and now it's changing to star. Sorry, it's going from star into delta. This is like a question I showed you. So what's the first step we should do? So motor C. I think Mr. Sima answered this last week. So you can see this is where the other questions get integrated into one, all the concepts, which surely you're going to get as well. What's the first step when we are moving one thing from another thing? Find the impedance exactly. Thank you very much. Can you guys quickly do that for me? I'll give you guys 5 minutes, not 5, well, up to 5 minutes. What's my impedance? 2 minutes have lapsed. So what we should actually get is our impedance at 50 hertz first, at the first frequency. So carry on. We need our impedance at the first frequency. That's what we need. Do I agree with the impedance? No, Mr. Ball. Remember, this motor was connected in star. And when we find impedance, we work on phase values. So please relook at that. Is that clear to everyone? Let see who's in the house. Mr. Plachis, you quiet. You guys get your impedance. Definitely not. Definitely not. Oh, the I value. What's the I value? Oh, no. Okay, let me start this off, right? So to find the impedance, you need V phase, I phase, Z phase, right? So in the first setup, motor C was connected in star, and it's applied with a 415 volts, right? We go to star to work, we have to work per phase, therefore we have to find 415 divided by root 3. So it's 415 divided by root 3. So that makes that 239.6 volts. Yeah, so the phase, there's 239.6 at 0 degrees. And our phase current, what is the phase current again? Someone just get that for me. Phase current was 208.68. Okay, 208.68. At an angle of no. Oh, sorry, it's connected in delta. It's connected in star. Remember, we're first finding it at the first condition. It's connected in star. Only then we have to take it into the new condition. So it's star. So at an angle of, what is the angle again? 38.74. Okay, so my Z phase would be 236. If you wondered why I needed the calculator, the Castle calculator, this is the reason why. 208.68 plus 38.74. And therefore we can get our impedance, the characteristics of the motor. No, this is just for motor C. Guys, is there any unclarity with this question? Please say it now. We're just taking motor C out. We're isolating motor C. The question states, the second decides to that motor C must be used. So we're just taking one question. I mean, one motor, not the total. You can only find the characteristic of the total load, but yeah, I mean, you're not really looking for that. You guys, any questions of how I'm going to find this? And can you please get that impedance for me? Impedance. Are you sure about that? That's not correct. Oh, sorry, it is, sorry. My bad. Yeah, we not assume positive, it is. It is a capacitor. That's the idea. That's the trick of this question. Because it's leading, it's a capacitor. That's definite. And you should get 0.8956 or 96 minus J 718. Something is, oh yeah, it's right, 785. Okay, 0.785. Oops. Yep. 717. Okay, now you got, well, yeah. So because this guy is negative, and you recall I said if you have a negative J, we know that it is a capacitor. So that's why I deliberately, for this particular question, this is a capacitor, not an inductor. If this was positive, it would have been plus J is an inductor. Is everyone content with that? That's a deliberate effort to this question. That's why I mentioned in the introductory part, if we have plus, it should be a capacitor. I mentioned something. Yeah, no, it's right. Yeah, so I was now thinking, hey, getting old. Yeah, so we have negative J, it's a capacitor. There you go. This is actually, yeah, something's bothering me. Yeah, yes, sir. Okay. If it's plus J, it's an inductor. That's how you know. So it's a capacitor. We need to find the actual capacitance value. Obviously, this is a very, the Topley motors are induct. We have to now find the capacitance at 60 hertz here. So capacitor value will be 1 over 2 pi f xl xc, sorry, subscript xc, and let's find that value over here. So it's 2 pi times 60 times 0.7185. And let me get my capacitor in farads. We're nearly there, guys. We're nearly there. We can go on a quick tea break and then start on the new section. Is there any questions so far, guys? Give me a thumbs up if you understand, and just give me the capacitance value.
So shouldn't we work out the farad and then go back to the 60 hertz?
You know, we are working the farads now, and then we go back. Then we're gonna go to 50 hertz. Am I confusing the two? Sorry. I meant to say, yeah, we're going. I said 50 hertz. Yeah, sorry. I made a mistake, man. I meant to say 50 hertz. Yeah, that's correct. That's 50 hertz. Sorry. I just confused the frequencies. That's 50. Yeah, there we go. I was saying this, yeah. We're going to 60 still, yeah. So now we need a capacitor value. 4.43. I'm assuming that's at 60 hertz, right? 4.43 millifarads. Can I just confirm that answer? Yep, that's correct. And now once we're done with this, we're taking this motor, same motor. Now we're having it at 317 volts at 50 hertz. So that's still motor C. And motor C has a characteristic value of, so I'll write like this: R is equal to 0.896, and C is equal to, this could be a synchronous type motor. C is 4.43 millifarads. And now, yeah, so now so like I said to you, your inductor and your capacitor, they are frequency dependent resistors. Frequency dependent resistors. All right. So what that means is that we need to find the new reactance at 50 hertz. So XC at 50 hertz will be 1/2 pi times 50 times 4.43. Guys, I'm boring you here. You find this exciting like I am. Amazing. Are you guys awake? Welcome to S4. Welcome. The best. It is the best, really. You can't beat this stuff. It's amazing. Look at this. Look at that board. Beautiful. There's more beautiful than any female could possibly be. I mean, just look at this. So let's look from afar. Let's just go back and look at this. Amazing. Look at this. How can you not love this? Stuff is crazy. Okay, let's find this reactance at 50 hertz. More beautiful than any woman which I could ever dream of. Look at that board. Okay, let's find that XC, and then obviously you need to find what's the question once again. I got so we need a new line current. How much current is drawing on the new setup? Okay, so I'll give you guys a moment to find that new reactance for me. Okay. What is our answer there? 0. Why does it look this? No, man. Can't be the same value. So it's 1 over, we had 50 hertz here. 50 times 4.43. Sorry, man, it's 60 hertz. Yeah, it's 60 hertz. Sorry. The question states 60 hertz. Yeah, we changed from 50 to 60. So I'm saying I'm completely. It's 60 hertz, guys. Sorry about that. It can't be the same. Yeah, 0.59877771 ohms. Cool. We got that. Yeah. Thank you, Mr. Ashipala. Oh, and Mr. Tuba. Cool. Nearly in the tea break time. Then we're going to go into power factor correction. Guess it's going to take all the time, which is fine. Okay. Now we need the current, right? So it's V phase equals I phase and it's Z phase, right? But now it's connected also in delta. Just revisiting the question. The container shop has now arrived at port. Second engineer decides to use motor C to power crane supply 317 volts at 60 hertz, and it's now assuming it's connected in delta now. Okay, so if that's the case, if it's in delta, our phase voltage will stay the same because V line, V phase, that's the same delta. We've got our new impedance, and our new impedance will be 0.896 plus, solid plus, negative J, 0.598771. Sounds like a phone number. Then we can get our I phase. And the last part, they did say they want the line current. So after this, we'll decide what's happening there. Okay. This question took over an hour. My Lord. Stop killing myself like this. Well, guys, concentrate on covering 3 phase with you. It's fine. Yeah, so let me get a new I phase. Yes, Mr. Mongo. Prof.
So that V phase there is not supposed to be 415.
No, Mr. Mongo, we had a new setup.
Oh, okay.
Yeah, we shifted from 415 to 317 at 60 hertz. Yeah, remember we're in a new location now. So 294.25, Dr. Swanepoel. 254.25 at an angle of, I'm assuming that's the 33.746. I'm assuming that is the phase. And what's the line current? Is it the line current or the phase? That's 509. Throws a lot of current. 509.6575 amps. That's a line. Obviously the same power factor. Plus. Cool. Amazing. Here we are. Any questions? Now we can head off into power factor correction. Nice. Okay. So any questions before I end session 1? Then we can start on session 2, which will talk to power factor correction. Any questions? Let me just check. There's your time to ask. Anything unclear, please ask Mr. Monro, Mr. Bason, Mr. Ashipala, Mr. Mark, Mr. Peters, Ms. Duba, Mr. Plachis. Any questions, guys? Mr. Jamini. Hi. Any questions before I proceed, before I conclude this session? Yes, you're going to. This came from a test. Yeah. Surely you're going to get a question like this. Definitely. It's not difficult in terms of the computation, but you need to think about it. You'll definitely get it. This was a test question. So you have to work fast. You get 3 questions for the test, total around 80 marks. So you can imagine it's like 30, 30, 20, or 25, 25, 25, or something like that. Each question will be 25 marks. There's no positive marking. What are you referring to? I thought you had a 245. Okay. 2 is 254, I think. 24 is 294, sorry. 294, yeah, sorry. I made a mistake there. It's no positive marking. You make no mistakes. 294, sorry. There's no positive marking. I thought you had a 245. It is, yeah. So yeah, you definitely can get a question like this. It's the nature of this particular section. Yeah. I mean, we just did this in 2 ways. You can actually do this in a lot less time. Method marking, it's long. No, it's no negotiations. Sure, I have to make sure you get it right. Any questions before we conclude this? I start on power factor correction. It's still the same type of stuff, but you're just going to add power factor correction at certain ends. Nothing difficult. There's a variety of ways I can ask any of these questions. If you remember the first one, the 2 alternator thing, find the one load of the other machine. There's just so many variations. I just expect you to know certain things. Yeah, concept must be clear. Method marking, it's long. Yeah, nah. You make sure you get everything right. If you study well, you should be able to solve everything. Yeah. Okay, I'm assuming there's no questions. Okay, guys. So let's have a 15-minute break, and then we will continue with 3-phase and then do power factor correction. We integrate it into questions. It's essentially the same vein, but we will obviously look at just including the power factor correction within the question. Still multiple loads, 3-phase loads, and then power factor type questions. Okay, see you at stretch your legs and see you at 3:45. So we have till 4. So yeah, cool. Coffee break. Go to 14:44. End of session 1. Okay.